Hello everyone, this is Kumar and today I'll be discussing on qualitative analysis on the performance of MongoDB and MySQL. So MySQL is an open source relation database management system where data are stored in tables, where MongoDB is a document-oriented database system where data are stored in JSON format. Now to handle huge amount of data, MongoDB uses load balancing technique. Under this load balancing technique, multiple servers are created and data are distributed among these servers. Now the shared key is generated, which handles the distribution of data among the server. This is called sharding. For example, if we have 1000 GB of data and there are 4 servers, then around 250 GB of data are distributed among these 4 servers, due to which the load on each server will get reduced and the performance of each server will get increased since they now have to manage only less data. This also leads to the horizontal scaling. Now we will analyze an experiment to compare the performance of MongoDB with MySQL. First of all, a web application is created where user can come and register into the website. Later, the user can log in again by entering the valid credential. Two similar data sets were created with 1 million records, one for MongoDB and one for MySQL. Same environment is kept for both of them, like Windows Server 2008 R2 and 4 GB RAM. After that, two types of tests were done. One is for insertion of the new data and second is for searching or retrieval of any existing data. For inserting data into database, user was logged in into registration page. The registration was done by adding same valid user details in both the database of MongoDB and MySQL. And now the time taken was noted down by using Fiddler. A fiddler is a debugging tool to capture network-related operations. Here we can see that for MySQL total time taken is 1.116 seconds, where for MongoDB it is only 0.283 seconds, which is 4 times better than MySQL. Now to search a data in database, login of same user was done with correct credential in both MongoDB and MySQL database. The fiddler showed that the time taken by MySQL to validate the user is 1.062 seconds, whereas for MongoDB it is 1.051 seconds, which is still better than MySQL. Finally, the graph is plotted for the total time taken for the insertion and retrieval of different number of records for both MySQL and MongoDB. Here we can see that as the number of records got increased, the total time taken by MySQL kept on increasing, whereas for MongoDB the time remains the same. So we can conclude that the MongoDB is faster than MySQL when the data is huge and does better scaling than MySQL. Now let us see some challenges of MySQL. MySQL does not work well with unstructured data due to its rigid tabular structure, and it is difficult to do any kind of quick modification in the structure whenever it is required. As the number of the data increases, MySQL fails on doing load balancing, thus making it less scalable. Furthermore, there is no inbuilt XML design unlike MongoDB, which make it harder to work with these kind of data. Now let's move towards the future direction. MongoDB Atlas is one of the key points for the future of MongoDB. By using MongoDB Atlas, one can easily deploy their code globally. In this way, it helps to keep the data close to the user, thus making it faster to retrieve the data from the server. Secondly, Shredkey, which manages the distribution of data across different servers, is also an important aspect. As the data goes beyond 1 billion records, there is a requirement to properly select a thread queue so that one server does not get most of the load and data gets evenly distributed among all the servers. Lastly, there is a need of better resilient process. Sometimes some server might crash. For example, if there are 10 servers and 2 get crashed at a certain point of time, then remaining 8 servers should automatically handle the load properly by the time the 2 other servers will come back into action. According to my personal views, in today's world, lots and lots of data are generated every day, and relational database like MySQL is not able to keep pace with them. On the other hand, MongoDB handles this data in a much easier way. Also, artificial intelligence and machine learning are so much into demand. So properly connecting MongoDB with artificial intelligence and machine learning can make a breakthrough in managing large datasets. Thank you.